Let's talk about solving differential equations by using the integrating factor. Now, when you have a differential equation in this form, where it has dy by dx plus py equal q. Now, p and q, they could be constants, or they could be functions of x. You have what is called an integrating factor. That's why what I put here as if. That integrating factor is equal to e to the integral of p dx, where this is p, alright? Whatever multiplies y is p. Now, here, let us multiply both sides by the integrating factor and see what happens. You would have e to the integral of p dx times dy by dx plus p y, but let's put the y last, p times e to the integral of p dx times y. Alright, so you multiply the left hand side, each of these, and then equal, and multiply the right hand side by it now. Q times e to the integral of p dx. Alright, now what you have on the left is called a differential coefficient. Now if you look at it carefully now, all of this here, what you really have is the result of differentiating something using the product rule. Alright? Remember what the product rule does? You have two things multiply each other, two functions multiply each other. You hold one function as it is, times, differentiate the next function, plus the function that you differentiated first, you hold it, times, and you differentiate the function that you held first. Alright? So, if you have the functions being a times b, when you differentiate, d by dx of ab is equal to, you hold a, find the derivative of b, multiply times, find the derivative of b, plus, then you hold b, times, find the derivative of a. Alright, so, here, what you do now, obviously you held something here and found the derivative of something else. It seems as if what you find the derivative of is y. So you hold e to the integral of p dx as it is, and then differentiate y with respect to x. So you have dy by dx. That's what happened there. But what's the second item that you have? Well, it would be y. That's what you differentiated here with respect to x. Now over here you would hold y as it is. So you hold y, then you differentiate e to the integral of p dx. Now, if you use the chain rule, you'll find that the derivative with respect to x of e to the integral of p dx is going to be p e to the integral of p dx. Alright? You can try doing that using the chain rule. Let u be equal to the integral of p dx. And then you will see how it works out. Right? With the chain rule. So this is really what you differentiated and use the product rule to get the left hand side. Right? So you found d by dx of this, right, with respect to x. So d by dx of that with respect to x. And that, of course, would be equal to q e to the integral of p dx. After that, you integrate both sides. you find the integral of the derivative of y e to the integral of p dx equal the integral of q e to the integral of p dx. So the integral and the derivative, both of them cancel each other out here. So you have y e to the integral of p dx is equal to whatever you get here when you integrate q e to the integral of p dx. Alright? When you integrate this, you add the constant of integration. You don't bother to add it on the left. You add it on the right. Alright. So when we do examples where we have actual numbers here, then all these things would be worked out. You could integrate this part and you will see how everything works out when it comes to using numbers. Alright? So we'll do that next in our next video. So I'll see you.